by Jaime Fernández. He will speak about the ILRS support to the Copernicus Sentinel 3 and 6 missions.
Okay. Thank you very much. My name is Jaime Fernández. I am working at GMV, and I give you this presentation, the ILRS support to two Copernicus missions, Sentinel 3 and Sentinel 6. So I will start explaining what is Copernicus PD service for those of you that are not familiar with, and then I will describe briefly the Sentinel 3 and Sentinel 6 missions, and then finally I will show you the support that you are giving us to these two missions. So starting with the Copernicus PD service, so for those of you that are not familiar, Copernicus is the European project for Earth monitoring. And within that, there is this Copernicus PD service, which is in charge of computing the precise orbits of the Sentinel 1, 2, 3, and 6 missions. This is led by GMV, a Spanish company, but we count on the support of 6 institutions, 6 European institutions, including POSITIV, the University of Bern, DLR, GFZ, TU Delft, and TU Munich. And this is complemented with the Quality Working Group, which includes not only these institutions, but also obviously all clients, which are basically ESA and EUMETSAT, and also CNES, CLS, JPL, and NASA in general. We generate basically orbits, you will see in the next, next slide, on 3 different timeliness. Basically near real time, we had to generate an orbit in less than 10 minutes. And then we have the short and critical. This is the following day, and the non-time critical just 1 month later. Okay. Obviously, the requirements are different. The requirements in terms of accuracy, it depends on the mission and it depends on the timeliness. Okay. So what we generate? Basically, we generate orbital products, precise orbital products for the scientific processing of the data of these missions. But on top of that, we generate also platform or attitude product for some of the missions. We generate the orbit predictions for the tracking, for the SLR tracking of Sentinel 3, not Sentinel 6, but only Sentinel 3. And we also generate, data, GNSS data, and also the quaternions for CNES, and in general for all the external users. Basically, there is a policy on the Copernicus project to give all the data to the users, to everyone in the world. So you can find not only the orbits, but also the GNSS measurements, the attitude of all these missions, everything you need basically to do POD on your home if you want it. All these services located in a public cloud, which is located here, close to Madrid. We have, a lot of machines, CPUs, but in general, I can say that we are supporting currently 4 missions. In total, we have been supporting 7 satellites. Now it's 6 because Sentinel-1B is not longer working properly. And in total, we are generating in the order of 100,000 orbital products per year. So that's quite a lot. In terms of interfaces, well, in order to do POD with GNSS, obviously we need GNSS products, the data, but we also count on you. We have also an interface with ILRS in order to do the quality control of the Sentinel-3 and Sentinel-6 mission. Very important is that we count, we have a quality working group that includes most of the centers worldwide that performs precise orbit determinations, mostly in Europe, but also JPL and NASA are included here. And why we count on all these centers? Because one of the methods we use to do the quality control of the orbits is something similar to what IGS is doing to generate the IGS final products or IGS rapid products. So a combined solution using all individual solutions and do a weighted mean of the orbital products. This is our main way of validating the quality of the orbits if the satellite has not a laser retroreflector, which is basically what happened with Sentinel-1 and Sentinel-2. But with Sentinel-3 and 6, we also have the ILRS, the laser observations. So Sentinel-3 and Sentinel-6, probably you are familiar with these two satellites, mostly if you are tracking them. So Sentinel-3 is an altimeter mission, but not only an altimeter, it has also other instruments, an ocean and land color imager, and a sea and land surface temperature radiometer. And apart from these two, it's an altimeter mission. That's why it is a laser retroreflector, in order to validate the radial accuracy of the orbit determination. Okay, and very important that probably most of you already know, not all the SLR station can track this satellite. It is a restricted tracking because this instrument, this camera, is sensitive to the laser, so it can be damaged if the laser track with too much power. So that's why not all the SLR station can track Sentinel-3. With Sentinel-6, there is no problem. So all stations can track Sentinel-6. The predictions are not provided by us, but by EUMETSAT. Okay, this is an higher orbital altitude and a 66-degree inclination. Okay, and has also a similar POD package, I would say, including GNSS, DORIS, and a laser retroreflector, which is very important. I mean, this is, I've been hearing recently that it is very important to have a common tie between different geodetic techniques, including GNSS, DORIS, laser. This has not VLBI, but we have 3 out of, in just 1 or 2 satellites. No? ILRS support. So this is more or less the map of the stations that are tracking Sentinel-3, probably also Sentinel-6, okay? There are many in Europe. Obviously, this is not a very well-distributed network, but this is what we have, obviously. Sentinel-3 and Sentinel-6 are, quite priority missions, as you can see, mainly Sentinel-3, as you can see here in the priority list of the SLR. And I can tell you that during the last quarter of this year, more or less around 15 stations has tracked Sentinel-3 and 25 has tracked Sentinel-6. This can be seen in these plots, on which for Sentinel-3, A and B, you can see on top, this is the number of passes since the beginning of the mission. So you have been between 50 and 100 per week, more or less. And this is the total number of passes per stations, where it can be seen that being in the desert of Australia has a benefit, indeed. During the last quarter, it has been quite stable, and these are the stations that has been tracking routinely Sentinel-3. The same statistics we have for Sentinel-6. Sentinel-6 is a little bit higher, so the number of passes is a bit higher because the duration of the passes are longer. Okay, and in this plot you can see highlighted the same stations that are also tracking Sentinel-3. So on top of those that are tracking Sentinel-3, we have some of them that are also tracking Sentinel-6. Okay, so one of the things we are doing every 3 months, but mostly every year, is that we generate a couple of reports that are publicly available and you can download from internet. I will send you the links, on which we are estimating the range bias per stations using this. I mean, what we do is to get this combined solution, which is a weighted mean of all these individual solutions. We fix that orbit and we estimate the range biases per station using 4 weeks of data. Okay, and you can see here for some of these stations the evolution of these biases. This is done individually per satellite in this case. Okay, I will mention this later. So these are some of the examples last year. Okay, this is corresponding to last year. In January next year, we will repeat this exercise for this year. Okay, and you can see how stable are these biases per stations. This is where it is explained. Well, some of the examples. This can be only done if we have enough data. I mean, for those stations have little data, it's not reasonable to do this. Okay, and I want to say that probably in the future we will change this approach, because you will see tomorrow there is a presentation by Daniel Arnold of a systematic error in satellite laser ranging validation of microwave-based low Earth orbit solutions. There is a new way to estimate these range biases per station, combining not only per satellite, but combining several LEO satellites, okay, which will give you a much better range bias per station. Okay. So with all these, once we compute these range biases, we recompute the residuals of the operational orbit, operational Sentinel-3, Sentinel-6 orbit, okay, and we derive which are the basically the radial error that we are obtaining. We compute this every, as I say, every 3-4 months. And also on yearly basis, we compile a big document from which these plots are extracted. Or we can see the evolution of these errors along the year. Okay? These reports are available in a ESA webpage, but also in the ILRS webpage. I sent this report for your information. If you have any comments to improve or to derive information, please tell us. I can also say that we are validating this new cost G geopotential that Uli has reported a few presentations ago. This ILRS, this SLR data is also used to validate this geopotential. I can tell you that indeed improve the results. And just to finalize, well, just to say that we are generating the Sentinel-3 CPF files with a very good accuracy, I would say. Conclusions, very simple. Sentinel-3 and Sentinel-6 missions are very important missions for altimetry. So we count on your support. So I just can tell you that thank you very much for your support. And that's all. Thank you.
Thank you.